Hello, everyone, and welcome back to our final presentation for the day in the data stream before we get to the ending keynote for today, day one of the conference. And we have something very special to go through now, which is the Unbreakable data pipeline. It sounds like something that I definitely would want. And our presenter is Herminio Vazquez, who is a machine learning consultant at the IOVO out of the Netherlands. I believe you're in Utrecht today, Herminio.
Yeah, that's
so. Herminio is going to tell us about top-class data engineering and how to build an unbreakable data pipeline. So, Herminio, over to you, and welcome to the stage. And everyone, please welcome Herminio.
Thank you very much, Jonas, for the brief introduction. I'll just share my slides. I hope that is visible. So I'm just going to hopefully make sure that everyone can see it. Welcome, everyone, to the Big Data Conference Europe. I hope that you're having a great day and enjoying the presentations. I'm very excited to be here today to present about the Unbreakable data pipeline. Let's get on to the brief. Just to explain a little bit who I am, I think it will be nicer to be in Vilnius talking with all of you and meeting in the corridors. But just a brief background. I started my career developing software for system-critical applications in GE. I'm very passionate about quality, as you will probably see during the presentation. I believe that good products require craftsmanship and some passion in it. In the personal side, well, I like traveling for work and for pleasure. I've been able to travel in 73 countries, and I'm really hoping that I can hit the 100 before my last loop on the sun. I like to participate in conferences to share my knowledge, learn from others, listen to what is happening in the market. And I've been gratefully invited to universities to also impart some seminars. And I think I'm a long life learner. I like to communicate with people to get to know that my interest to learn languages, play guitar and piano. My wife is a French doctor of science, so our breakfast mornings are really interesting discussions about everything. As you can see, she's proud about teaching me one or two things. I call her Chiquipedia. I have two sons, Nacho and Antoine, and the fun fact is that one liked tacos and the other one cheese. Okay, let's get into it. Today, the agenda will be looking into how to build an unbreakable pipeline. For that, we will look into a toolkit. We will also go through what is the secret sauce for building a pipeline, which I will suspect that by the emojis you are thinking about experimentations and metrics. And finally, we will go through a series of checklists that will hopefully provide you the background for what is required to construct something reliable. I must say, where does this idea started? I think as you progress in your career, when you come out of college, you look into your career and perhaps you are looking for a great salary compensation. I think as you move across the ranks, you realize that you would like to be next to very successful people or people that you can learn from. And at the later stage, perhaps you are trying to make your work meaningful and you would like to somehow transcend in the way that you create things. I think the information industry is not an exception. I think you have the ability to create things that more than satisfying clients and of course the value creation. You can also satisfy yourself and create that sort of proudness of what you have built. Breaking or building unbreakable things, you will have to break a lot of things. Think about buildings or I don't know, toys, right? The choices are numerous. There is very much a lot of ways to think about unbreakable things. You can think about bamboo being very flexible, or you can think about cast iron to be unflexible and probably, or titanium or carbon, almost indestructible. We would like to, or during the course of the presentation, I would like to touch upon these points about flexibility and hardness, and make sure that we understand these concepts with the idea of building these unbreakable data pipelines. I didn't really ask or took the time to go through what is a data pipeline. I will assume that if we are in this track, we understand that it's just the transfers of data or the connection between decision engineering and a data point. And I guess the first thing to address, or when thinking about building an unbreakable pipeline, is to have a CI pipeline or a continuous integration pipeline and aligning with your team. What this means is that we will have to look into standards, perhaps a semantic model that describes the entities that govern the business that you are working at the moment. You will also have to make trade-offs between what is the common set of APIs that your team feels more comfortable developing with, whether it's an API base or perhaps it's SQL. You can see now that a lot of industry leaders in the area of data management or data governance in general are trending or using these two approaches, whether a Python or a Scala API, or perhaps instructions based on SQL, because the community of SQL is even bigger. They can reach a bigger audience. And also on team alignment is also the set of conditions or expectations that you're expecting them to follow during the construction of these pipelines, which in reality is about documenting or maintaining a good ratio between the amount of information that you share about the knowledge and the rules, and closing your pipelines, and of course the testing. Now, team alignment. Let's first find the people that can break the pipelines, right? Our first step here will be to analyze what are your strengths and your weaknesses, right? Opportunities and threats, and more than anything, leak detection. We would like to make sure that when starting in a data engineering team, we find out who is the person who feels more comfortable developing ingestion pipelines or transformation pipelines, what is their acumen or their understanding about the business terminology, how easily they adapt to change, how familiar they are with the common things about repositories, right, or branch conventions, like feature branches need to be prefixed with feature, or release branches will also need to be tagged. What is the familiarity with metrics that help understand the complexity of the code developed. Science and a lot of studies have shown that the different metrics that there are on software engineering, like cyclomatic complexity or cyclomatic complexity or cognitive complexity, are really good indicators, not to tell us how good or bad things are, but simply to help us understand if we are embarking in a lot of technical depth, or if our spaghetti is code, or if the things that they are developed are unmaintainable or readable. Code styles, adoptions, and knowing that we need to build to last, not to expecting that at some point, one sprint, you will be able to refactor. All these alignments and things about craftsmanship of what the things that you do are very important to start or to kick off this idea of reliable or indestructible pipelines. It will be very ambitious to go through every single detail about it, of how to do it, but I would like to just provide you with cues about what kind of things can help you develop or harness this idea. One of the things that we embrace as a team, or I embrace together with my teams, is the idea of creating good habits. There is a possibility when working with Git repositories or GitHub repositories, in the same way that you can implement actions or predefine activities on certain events on your repository, like commits or pull requests. There is also these templates. These templates allow you to create markdown-based templates with activities or checklists that will allow your team to go through the different things that you are expecting for them during the life cycle of a pipeline. And this, in a specific, this template refers to an ingestion change. And here, as you can see, is just addressing whether schemas are defined, the stroke types or the definition or the data structures to define the schema are also added to the repository. Readers for specific types of data sets are included. The old references is just to make sure that you have code completion if you're working with a specific IDE. Doc strings as well, so well-documented code, so that means that people can read what is going on, or even functionality that adds or increases the scope of the pipeline, and also about refactoring to less code or optimization activities. So PR templates are really, really good to have. The other thing that I will also recommend is it's amazing the amount of time that we spend reading code. And if you are a high proficient team, you will see that most likely you will start reusing or libraries or functionality or data points that are being produced or computed by other teams or by other members of your team. Having readable code is paramount to building reliable and indestructible pipelines. As a reference, I would recommend to have a read on the Palantir PySpark style guide. As mentioned in the introduction, this session is leaning towards the idea of building pipelines with Spark and PySpark computing framework, and therefore the reference for having a look. These little details are also what makes your participation on a team more pleasant than not. So the reason to bring it up as part of reading code and accessing quickly to information is part of making maintainable pipelines as well. Okay, so we move to this first checkpoint, right, of our journey about creating unbreakable pipelines. So what we talk about is we need repositories, right? I cannot anticipate a digital delivery team without change management in the sense of having Git controls or version controls. Repositories today are I squared plus T, I call them, because they are infrastructure, ingestion, and transformation. Whether you would like to operate in a monorepo or separating concerns across your repositories, you will definitely would like to make sure that either your on-premise or cloud infrastructure is governed by replicable scripts. What this means is that your repositories have standards and actions defined. Your team is onboarded with the right permission model, so you know who can read only the repository and who are the maintainers, master on the branches, etc. There is a clear branching strategy so that you can clearly connect or have traceability about the features that you were adding through your transformation or your ingestion or even your infrastructure in the case of modernization. That moves us to the next check. So to build reliable pipelines, you need a build pipeline in which you don't see, for instance, Notebook as unscalable or as a rapid development. Notebooks are amazing. I spend a lot of time enjoying and operating in this environment because of the flexibility and the fast response of computation and a lot of the nice things that you can do in notebooks, but they are per se not software components, right? You cannot, you can probably, but I would say it doesn't follow the practices of building a software or having a particular version. You can have a notebook, but in my experience, it's a little bit more difficult. In fact, I see notebooks more as a way to put it in pandas, and a lot of data teams that I hear in different places, they are in fact just transforming these pandas notebooks into PySpark or distributed computing frameworks. You need testing, of course. The idea of building pipeline is also with the background of having a unit test suite with synthetic data. And in this area, some of the things, I guess, also to to build more reliable pipelines is to make associations about the folders that you can trigger a specific test depending on where the changes are coming. You don't want to build up your documentation or run tests on schemas or run tests on specific readers if there is no change on those things. So the idea of allocating paths for triggers is very important to save time as well. Releasing pipelines is a very important topic. I mean, the idea of making something unbreakable is to pretty much target areas of change. So in this continuous integration and continuous delivery afterwards, we are talking about the areas where we change. We need to see change as a train, right? We cannot stop it. And my comment here is try to remove as much as possible the human intervention. Try to do as much replicable, and I think these are just the DevOps principles being brought to data ops in general. The idea or the concept of rolling out functionality and data sets, especially when you use, for instance, Delta Lake that allows you to travel in time, you might need to incorporate these concepts too. Now you can release versions of your pipelines, ingestion and transformation, but also versions of your data. It might be you might be wearing a high cost if you want to expand that, but you can also revert back or have this historical. One of my experience here is to know who has the power to do these time travel transformations. When you said you can do it, that means that great power comes with great responsibility. And the last part is observability. The job is not done until you have metrics. And I think there is even manifestos or references in which data ops looked into this part in the maturity of teams. But I guess if your aim, again, is to build very reliable and indestructible pipelines, you would like to make sure that you adopt the metrics first. And where you have, for instance, notification hierarchies, you don't want to have a problem in your storage layer being notified to your end users, or I guess in this algorithmic era, you don't want to end up setting thresholds for everything, where statistical inferences can help you to diagnose these things pretty much dynamically. Now let's move in a little bit faster. If you want to build indestructible pipelines, you need dictionaries and schemas. Let me walk you through what I mean about the dictionaries. I mean, eventually, all organizations should have a semantic model of how their business look in terms of data. That means that you will have a set of definitions of the entities that describe your business, and eventually these entities will have attributes, and these attributes will be mapped to fields and the data sets that you are dealing with. You have external data and internal data. For people that are working, for instance, in asset management, like I do, we receive a lot of information of data sources, text-based from external parties, and we receive dictionaries in PDFs or Excels or Word documents. What that means is that we will have to capture those definitions, create trees or semantic trees about the connectivities of these dictionaries, and then translate them into machine-readable formats. Data dictionaries enable us to create schemas. Schemas is simply having descriptions and data types, and those are required, of course, to make data algebra or transformations or computations, aggregations, etc., numerical computations as well. Now, data types without metadata, I normally say they are useless, right? I'm not sure. I think I already lost the count of how many times I've interviewed data engineers that have solved a time zone problem. I swear probably it's going to be more than 100 times. So the idea here of dealing with time zones, time lengths, decimal separators, understanding that the internationality of data is becoming ubiquitous on the industry, it's important to have a good reference about. So definitely you need dictionaries and schemas. Now, that brings us to a dilemma. Where should we put our schemas? I mean, if you look at the history of this object, there have been bringing it as a service outside, the registry, the atlas, the different places. In my experience, depending on the amount of change that your team intakes in terms of the data, I have found that the idea of having those schemas in the repository is very beneficial, especially because then we can immediately trace all the structures that are drifting. Now, this is also accommodating the new facilities of a schema evolution, right? So even if you define a predefined schema or a set of or a subset of the fields that you are expecting, you can still delegate part of this functionality to the formats that you operate with, for example, Delta Lake. In the other side, when you look into schemas that are governing external parties, well, then you need to think about what is my technical tax on this. It might be that I'm using Alation or Colibra or any other tool that allows you to define schemas or definitions, but then you need to find integration points, and that elaborates a little bit more in your technology stack. In my experience, there is also this out of sync that the schemas are never updated, whilst when they're maintained in the repository, trying to keep things up to date. So in this case, it's more convenient. One example as well is, for instance, when using cloud technology like Azure Data Factories, you have the ability to create those schemas, but then they live and die inside of this of the application. They are not portable. If you want to show them or version them, it's also more difficult. These platforms of low code, there is still code, right? But somehow you don't see it. You see it more as JSON. Now, schemas, let's not see it very complex. A schema is something very simple. It's just a field, right? We describe the type. We say if we expect them or not, and then the interesting part here is about the attributes or the metadata on the schemas. And the nice thing, for instance, of Parquet or Delta Lake is that allows you to enrich schemas with as much attributes or meta information as you want without the cost of storing it, and that is very important, because that means that even when people are reading your data sets and you are embedding these schemas in it, they for free get descriptions of what it is and perhaps taggings or meta information that allow them to create associations about the entities that they are dealing with. Now, building schemas, I sometimes are very surprised to go to organizations starting from scratch, as I said, of the hiring data engineer subject. There are a very extensive list of international standards that help us navigate through these different data types or specifications, right? From currency codes to country codes to data quality and master data to information security. I'll invite you to go through this in your own time and your own pace. But these in particular are, well, task forces, right? Like the Internet Engineering Task Force that defines, well, what are the standards or the expected formats of these particular values, or how you can use them through ingestion. There is even Python bindings to some of these, the ISO 3339, I think it's implemented. So it's very easy to use, and it maps, again, to the idea of banding it with the schema. Now, if you said, okay, building Unbreakable things allows you to create more testing or validating, well, you can validate the schemas. JSON schema validation is just to say if you receive a time or a date, you will expect as a minimum a time zone or a format of that particular date. Testing schemas is also not a problem, right? If you create PyTests that read all your JSONs, that means that you are in 3 lines of code ready to validate all the schemas or the structures that you are dealing with. So there is a lot of benefits of having a schemas: shifting quality left, capture data drift, lowering the cognitive load of complex canonical models, reduce the times to the insight. In general, the idea of managing metadata in a very primitive and low-level way, but still is an entry point. And it's also the idea of having a good data semantic model that helps you with this metadata, of mapping attributes group to the metadata that you hold in your schemas. Now, having schemas doesn't resolve the problem of building a reliable pipeline, but a delivery framework does. So you need to have a strategy to test your pipelines. And that relies in the fabrication of synthetic data sets or smaller data sets. All the dimensions that you can think of are accuracy, completeness, consistency, currency, integrity, precision, privacy, reasonableness, timeliness, uniqueness, validity, and accessibility. If you have find something more that you think is not in there, I would recommend you to be part of the group of experts defining these kind of things and sharing them in the data management knowledge book as reference in the slide. Quality is also adopting a framework. I personally have a preference for PyDQ. I think it is very powerful, it's easy to implement, and it provides analyzers, checkers, and verifications that helps you get started very quickly. Now, this is the quality funnel. The quality funnel is very simple. You either check that your data arrives, and there are now solutions, for instance, in Databricks, where you have cloud files that you don't have to worry about the arrival of times or the analogies between the streams and batch. You need to find out if data is coming with a specific number of rows. You will have to verify that the headers are the subset of your schema. You will also have to make sure that the column names are SQL standard. Sometimes when you are trying to save a column name that doesn't fit in the SQL standard, Delta will cry. You will have to verify that they fit in the specification. Some, as I explained before, in my current project, we receive data from providers, and the only thing that they tell us more mainframe style is that this field is this length. So no data types, no inference in that regard. So we need to look into just the fitness of the values. A word of caution when looking into castings. Spark, when casting a value and not being able to cast the value, will automatically convert it into null. So one important aspect when you believe that a data point or a field or a column is of a specific type is to make sure that you baseline and benchmark your null value. So in that case, you can see, instead of forcing the things to say break it if it doesn't really fit. And we will go in a second in the reason why. And then the readiness is when all the business rules that you would like your data sets to comply with, completeness, uniqueness, precision, integrity, etc., these are more business-derived rules, are also implemented in this particular funnel. There is multiple ways to do it. I've seen people putting rules in a database, creating very complex spaghettis of tables and things just to run the DQ framework. I've seen also strategies where you put labels or decorators like delta live tables as well from Databricks, or other approaches in which you can cover more things. I would say make it simple. I think that the quality is so simple. It's just an expectation and the idea of having a quality policy assigned to a particular data set. Going through this framework, one important aspect is that you cannot guarantee that all the records fail or pass, right? If you want to make something reliable or unbreakable, that means that you have also the flexibility to deal, for instance, with quarantine records. If you are receiving CSVs or text-based data, for sure you might encounter at some point in your data engineering lives the idea of having quarantine records. Spark allows you to do that, and we will see it in a minute. But also imputation policies. If you want to reduce the time for insight overall, or the value of data engineering, you don't want to be involved with specific business groups to find out in which way you can resolve these conflicts or these quarantine records. And finally, data sampling, right? There is always a trade-off between the cost and the benefit. I will always try to pursue the benefits of having samples of data from production, masked and transported to the test environment. In that way, that avoids the defect paradox, right? That you are testing always with the same thing. Considering that you also complement this feed of data with your own fabricated data. Remember that the data that you have in production somehow has been sanitized or have passed through different levels of validation, and you still need the error and the exception handler triggers, which is data that you don't have in production. And this will also help you to understand the dynamics of the data. Handling malformed records. So this is an example of the modes that you can use, for instance, in PySpark to deal with malformed records. And you need to tweak, right, your readers or the way that you're reading text or CSVs in a permissive mode. Recently, I found that you cannot make queries into the malformed column without caching your data frames. So a word of caution as well, when you are dealing or trying to filter specific malformed records just to put them in a quarantine area, it's important that you perform a cache of your data frames before. Ingestion can be as simple as a group of computations, right, or functions that will consistently and iteratively pass your data frames. It's important to provide feedback. So even warning the users about the idea that have quarantine records or records that have been malformed, but is still present so that they can be dealt with, is very important, but it's still not making your pipeline breaks or throwing exceptions just because a few records, let's say 2 out of 40,000 or 400,000, I don't know, have issues. So this is also very important to make your pipelines more reliable and to have the flexibility to deal with this quarantine approach. The same applies to transformations, right? We have been talking more in the journey of the data, right? We ingested. At some point, you will have to join data sets and enrich them or create a specific computations, aggregations, all the demands for your business users. Transformations, I would recommend or to use the pipeline functionality available also in PySpark, so that you can build in the same way that you will do, for instance, with scikit-learn of estimators and regressors to put them in a pipeline. One of the rules of engagement for the team is that all the rules that we implement inside of our transformers, like for instance this that is shown on the screen, of forward filling, it's a very let's say common pattern for imputation, right? So we said, okay, if the value for today is not available, look 5 business days before, and then forward fill this value according to these particular rules. And those rules are documented in the code so that we can also identify and quantify and inventorize all the rules that we are dealing with in our transformation pipelines. In the last part of the presentation, so now we are building a story about this Unbreakable pipeline, right? So at this point, we are reaching where we have repositories, we have rules of engagement, we have a semantic model, we have flexibility to deal with ingestion, we have alertings and notifications, our team is trained, our people is qualified to do this job. We understand what are the dependencies between one thing and the other. We have schemas that tell us which data types we need to do. We are managing metadata. And we reach this part, very important part, I would say, is part of the definition of done, in which we need to find telemetry or information about the operation of our pipelines. Metric-first approach for everything. Infrastructure, logical entities, computation, always visible results. The idea of profiling your data, as I mentioned before, the journey of the data doesn't end up in the production storage. The journey of the data finishes in a circle, bringing samples of fractions of those data sets to feed them back into the ingestion in our testing pipeline so that you avoid the defect paradox. And more than anything, fight for simplification. There is really all the YouTube engineering that is happening nowadays, in which creating and building more is part of the common pattern. And I think there is more necessity of bringing or reducing the complexity of things as much as we can. The landscape is dangerous, so navigate with caution, but try to always go for the simplification. For less is better. I didn't address architectural aspects in this talk on purpose, but I will assume that, in generally speaking, all data platforms are conformed with certain characteristics: storage, computation, visualization. I did mention that there has to be a connection between your decisions, the decisions made, and the data points that support them, these decision engineering concepts. This is also coined as actionable insights or the value of data science. But in general, we are saying you are better prepared when you arrive to a meeting or a discussion or a business decision with some data sets that support you. Now, having this holistic view from the operations side of things, you normally will think about a DAG or a direct acyclic graph, in which you will see the dependencies between the jobs and a holistic view of what it is. You have out-of-the-box tools like factories or like Airflow or like Daxter that allows you to create this view or holistic view about all the things and the pipelines running in your business area. Pursue this, right? It's important to see this schedule of where things are, and something as simple as a punch card, it's sufficient for you to have this minimum visibility as opposed to go to the granular level. This is preventing your team or your stakeholders navigating through logs. The idea of observability of your data pipelines is very important. So build quality in through telemetry as opposed to testing quality out through monitoring. Of course, I mentioned something before. You need to also understand the appetite and the maturity of your organization. There are organizations that are very mature and they are living in the report area. So send me this report, or I need a PDF with an email with all the information about where these things are. Or the culture has evolved a little bit into the need for more, to the dashboard organization, where you are presenting a lot of metrics, and then you end up with people asking, okay, so is the red positive, or is the green good, or what does that blue mean? So then knowledge is ephemeral, right? Everyone make their own inferences about what they see, and there is literally not connection between what you're trying to communicate through a visual queuing of the information or encoding of data and the people perception. Then you move to a do-it-yourself approach, in which the people are requesting the data in order for them to create their own dashboards or interpretations, most likely in Excel or some other tools, I don't know. And finally is when I guess the more mature organizations or the more advanced organizations have the ChatOps approach, in which you can say, okay, what are the last data sets that were ingested? Can you please tell me how much customers during the last hour? And then the bot will actually encapsulate the knowledge of the organization and start responding this. This is on higher levels of higher degree of automation and higher degree of knowledge sharing in the organization, but it's still possible. And with this, and giving sufficient time for questions, I would like to thank you all for joining the session of Building Unbreakable Pipelines. I hope that with this talk, you go back to your teams with the spirit of trying to break something that perdure and endure for a long time. So thank you very much for your participation.
Thank you so much for that very in-depth presentation, Herminio. I have lots of questions, but I'm not sure that I will actually have time to ask them, because we also have lots of audience questions.
Okay.
They of course come before me. So we'll go from the top. We have a question here from who asks, could you please recommend any technologies or solutions for achieving data versioning?
Well, Delta Lake is a format and is pretty much a Git for your data. You have a vacuum approach that allows you to, by default, maintain 1 week of data, but literally it maintains a transaction log of all the data that has been updated or has been appended to the files. Delta Lake also offers ACID transactions, so that means that parallel streams of work can actually append or work in the same operation, so those have ACID guarantees. So data versioning definitely matches with this open source project of Delta Lake, not to be confused with Data Lake, which is an architectural pattern, but or the lake house. But those are, I would say, my recommendations in order to find these versions. And it's very important nowadays. When you release new pipelines, you also sort of release new data, so you have the ability to say, okay, hold on, I can get back, right, to a previous version.
Great. Next question is from Anas, who asks, how much time do you save using this structure? And have you always worked to have this type of order in the code?
This is part of a long journey, right, of learning. But what will help you to convey the message of why this structure is how much time would you take from the moment that you have a new data set till the moment that you have it in production, documented and governed. Data governance is very abstract, but just imagine that you are a citizen of a country and you need a passport to go around. Data sets are exactly the same. Before you bring them to your home or to your city, you would like them to be described, right? Who are your parents? Where are you from? Where you were born? What is your, I wouldn't say lineage because that is probably from the Middle Age, but at least what is the provenance, right? Are you half Mexican, half French? So these kind of things are something that you need to put in place in order to have not a swamp, but an actual analytics platform, data analytics platform. That being said, the time that you take from getting the reference of the data to the moment that is accessible to your users is normally what will define the success factor of your pipeline architecture and definitions. What I've showed you, or what I put in the slides, is literally 10 minutes. From the moment that we receive schemas, the whole process from governance to ingestion to transformation to delivery, it takes about 5 to 10 minutes. So access for decision making, especially in asset management, is very important. And therefore, it's also good to have these metrics that support the decisions that you made as a team in the technology that support these platforms.
Yeah, a short time, and I saw a lot of risk management in what you were doing as well, which is, I assume, a huge part of it. So, Asad says, thanks for the presentation. Did you mention anything about returning data back during... Oh, just disappeared, sorry.
Returning data back, rollback during
my screen's jumping. Sorry, I'll get back to it. To returning data back or rolling data back during some fails in the pipeline.
Yeah, bear in mind that there is. I will mention two scenarios here. If you are thinking about batch processing, semi-batch, micro-batch, you will think about releasing a pipeline and then afterwards running triggers or having something that moves data. Right now, the point that you are releasing this code or this transformation or ingestion doesn't guarantee that the data will be processed. So in that regard, you really need to go back in time as of what the data and your state of ingestion transformation development or releases were at that point in time. So yes, I would say when you revert back, you want to revert back and reprocess. That's also following certain architectural patterns like immutability, right? Where you said, okay, all the computation that I do, I don't persist anything, I will just recompute everything again. So it's like looking into different things with different glasses. So yes, there is the concept where you can revert back releases of software and you can revert back previous releases of the data because you don't know if there have been other files ingested at that point in time. So you would like to make sure that you can time travel also in the data. Delta Lake is one of the, I will get things that are, let's say, fostering the widely adoption of Delta Lake because of these time travel capabilities.
So last two questions. Yola asks, is there a way to access the slides after the talk? I'm assuming you're very happy to share the slides and we'll make them available.
Absolutely, I will. Yes.
So we'll make them available. And the second question from Asad is, what do you think about the data mesh paradigm?
Excuse me, what was the last question?
Data mesh paradigm.
The data mesh paradigm. Well, again, this whole, let's say, presentation has been looking into a problem from one angle, right, or from a couple of different angles. It's, of course, this is not let's say, preaching. It's just sharing a story about how do you see things. The data mesh paradigm is also very interesting. I mean, there is different canonical patterns that resolve, but it also brings more complexity and dependencies And the whole point, I mean, to answer objectively your question is, it depends also in the nature of the data sets that you are dealing with, and the interdependencies that you would like to create between the entities that define semantically your model, right? Data mesh is very powerful on interconnecting or getting data sets linked, but it might be that the degree of independence of the data that you are willing to operate don't really capitalize on this particular pattern. That would be my answer to the question. Which again, it depends on the problem definition.
Herminio, thank you so much for sharing your knowledge with us today. Really appreciate it. And on behalf of the audience, I want to thank you for the detailed presentation that you went through. And I learned a lot. I hope everyone else did as well. Now, for everyone listening, we have 15 minutes until the final keynote for today, which is, well, actually we have 13 minutes now, which is at past. So go and get a glass of water and do what you can do in 15 minutes and come back for the final speech today. Herminio, thank you so much for sharing your knowledge again, and enjoy your day.
Thank you very much, and have a great day, guys. Keep on enjoying the sessions. Goodbye.